Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagmani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So as you all are aware that we are presently going through the lecture series of Introduction to Programming using C++. For today's lecture, our topic is virtual functions. So before coming to virtual functions, let me allow me to recall we have polymorphism as one of the main features of object oriented programming paradigm, and within that polymorphism we have learned that there are two types of polymorphism as far as C++ is concerned. One is compile time polymorphism, another is runtime polymorphism. So let me specify that virtual function is actually a way to achieve runtime polymorphism. Now what actually this virtual function is, considering the concept of inheritance, you all are aware that we have one base class and another class which is which is inheriting the features of base class is the derived class. Now let's say we have one function which is similarly we can say declared, one function which is present in the base class as well as present in the derived class both. So these type of functions, using these type of functions we can implement our virtual functions. So virtual function is actually a type of member function which is declared within a base class and it is redefined by a derived class. For example, we have one function show which is declared inside the base class and one function show with the same prototype. Yes, please note that I am insisting on the word with the same prototype, because if I am going to say with the different prototype, then this will be simply overloading, and overloading is nothing but compile time polymorphism. We are not studying overloading here. We are not studying compile time polymorphism. We are studying runtime polymorphism. So member function declared within a base class and redefined by the derived class. And while referring to the function within the derived class, that may have its own kind of a different definition. That means when we refer to a derived class object using a pointer or a reference to the base class, what are we going to do? We are going to create a derived class object or object of the derived class, and we are going to have a pointer or maybe a reference to the base class. A virtual function can be called for that particular object, and that version of the virtual function will be executed which is present in the derived class. So let me kind of recap it. We are having some one pointer or maybe one reference to the base class, and in order to call the derived class version of the function, we need to call the virtual function with the help of that pointer, and within that pointer or within the reference we are going to store the derived class object. I'm going to show the code here in a short while. So basically what are we trying to do here? If you can see, as I have told you, that we have one function show which is in the base class as well as in the derived class with the same prototype but different definition. That means the function of these we can say members is different. One function show within the base class is having one task, and one function show within the derived class is having another task, but the prototype is exactly same. So prototype is same, that means we have only one interface, one prototype, but there are multiple methods in the sense we have derived class 1 with the function show as it is needed in derived class 1. Then we can have derived class 2 with its own version of show. Then we can have derived class 3 with its own version of show and so on and so forth. So only one interface is there and there are multiple methods, and which particular method is to be called that depends on our programming. So in order to create a virtual function, we need to precede the function's declaration in the base class with the keyword keyword virtual. That means we need to place the keyword virtual in the function declaration only in the base class. Please note, only in the base class, not in the derived class, not in any of the derived class, neither in derived class 1, neither in nor in derived class 2 or any other class for that matter. So, in order to create a virtual function, we need to precede the function's declaration in the base class with the keyword virtual. That is one thing we need to make sure. And when a class containing a virtual function is inherited, because we are doing this virtual function inside the base class, so definitely this base class will be inherited by some other derived class. So whenever this class containing a virtual function is inherited, the derived class redefines the virtual function to fit its own needs. That means derived class 1 is having its own version of show, derived class 2 may have its own version of show, and derived class 3 may have its own definition or its own version, but only one interface with the similar prototype. So, I am repeating, when a class containing a virtual function is inherited, the derived class redefines the virtual function to fit its own need. That is why we call this mechanism of virtual function as one interface multiple methods. That is the jargon term which is basically used for your virtual functions, one interface multiple methods. Now how it is one interface multiple methods, let us try to drill down into it more. The virtual function within the base class defines the form of the interface to that function. Whatever virtual functions within the base class we have given, that defines the form of the interface. So we can say we are having the prototype defined inside the base class, and definition, individual derived classes will be giving their own definition. So each redefinition of the virtual function by a derived class implements its operation as it relates specifically to the derived class. That means according to its own needs, derived class is going to redefine that particular function, which function is defined as virtual inside the base class. So basically what are we doing? We are redefining a specific method. Which method? Our virtual methods or our virtual functions. We are giving the prototype or the form of the interface within the base class, and as per the requirement, all the derived classes which are inheriting that base class will be giving their own implementation to that particular virtual function. So virtual function ensures that the correct function is called for an object regardless of the type of reference or of the type of pointer used for the function class. So I am repeating it again. Why? Because this is very important. Virtual functions are there in order to ensure that correct function is called for an object regardless of the type of reference or of the type of pointer used for the function call. So it doesn't matter that which particular reference or which particular pointer is used for function call. If the function is declared as a virtual function inside the base class, then virtual function will ensure that the correct function will be called for the object. How? That we will see in the coding. So basically they are there to implement or to achieve runtime polymorphism. That means which function is to be called, that will be determined at the runtime, not at the compile time, and these functions, as I have told you, will be declared by using the virtual keywords in the base class. Resolving of function call, that means which function is to be called, that resolving of function call is done at the runtime. Whenever we are having same name but different interfaces, I am talking about function overloading, that resolving of function call is done at the compile time, not at the runtime. But this type, when we are talking about one interface, multiple methods, this resolution of function call is actually done at the runtime, not at the compile time. Now, the another question which comes in mind, can we access these virtual functions normally? Yes, we can access these virtual functions normally as well. Then they will behave just like any other normal class member functions. But if you want to achieve the advantages of runtime polymorphism, then virtual functions are important because they are capable of supporting runtime polymorphism, and this is how and in order to support the runtime polymorphism is actually something that how they behave when accessed via pointer or maybe via a reference. So when a base pointer points to a derived object that contains a virtual function, C++ determines which version of that function to call based upon the type of object pointed to by the pointer, and this is determined at the runtime. When a base pointer points to a derived object, the pointer is of the base class, it is pointing to the object of a derived class, and that derived class is having a function which is being declared as virtual inside the base class. C++ determines which version of that function to call, derived one which is defined for the derived class 1, which is defined for the derived class 2, or maybe depending upon which is defined for the base class. So C++ determines which version of that function to call based upon the type of object pointed to by the pointer, based upon the type of object pointed to by the pointer, and this is determined, this decision is taken at the runtime. So when different objects are pointed to, different versions of virtual functions are executed. That means we will be creating pointer or reference to the base class, and to which particular function to which particular object these pointers are pointing to, that determines that which virtual functions will be executed, and the same effect can be applied to the base class references as well. Now, in order to understand this whole concept of your virtual functions, let us see a small program. Within this program, we have taken one class which is the base class, and within this base class we have defined or we have created one function which is named as vfunc. Now it is having the prototype of void with return type of void with no parameters in the list, but as we want the derived classes to have their own version of virtual functions, own version of this vfunc, we are defining this function as virtual. So as you can see in the code, we have given within the definition of base, we have in the public section we have a function in the name of vfunc, which is a virtual function, and it is simply printing this is base vfunc of base, or this is basis vfunc. Then we have a derived class, and within that that derived class is inheriting this base class which is defined just above, and within the public section of that derived class we have one vfunc. Now please notice there is no keyword virtual when we are redefining the function inside the derived classes, whether it is the derived class 1 or derived class 2 or derived class 3 for that matter. We need not to precede the virtual function or the function which is going to be virtual with the keyword virtual. This is to be done only in the base class, and this will give the indication to the system that this function is virtual, and whenever this base class will be inherited by the derived classes, then in those derived classes will be giving their own kind of implementation or own definition for this vfunc. And within this vfunc, inside the derived class, it is printing this is derived one's vfunc. Then we have another class which is class derived 2, and that derived 2 class is also inheriting the base class in the public mode, and within the public section it is also having one implementation of its own vfunc, which says this is derived 2's vfunc. So that means what we have done in the definition of classes, we have taken 3 definitions. One is for class base, another one is for derived class 1, and third one is for derived class 2. So derived class 1 and derived class 2 are inheriting this base class, and base is the class base is the parent class for these derived 1 and derived 2, and we have defined vfunc for all the 3 classes. Within the base class, we have preceded this vfunc with the keyword virtual, or in the others, in the derived 1 and in the derived 2, we have declared, or we have defined it as a normal function, we can say. Now this was kind of, we can say, the section of class definition. Now coming to the main function. Now within the main function, see what is happening. Firstly, we have created one pointer which is pointing towards the base class. That's basically a base class pointer. Then we have, and that is shown here with the name, with the variable name as p, and base asterisk p means that is the kind of pointer which is pointing towards the base class, or more technically we can say that will point towards the object of the base class. Then we have one object of the base class which is b. Then we have one object of the derived class 1 named as d1. Then we have one object of the derived class 2 which is d2. So now 3 objects, object of the base class b, object of the derived class d1, object of the derived class 2 as d2, and we are having one pointer which is pointing to which is the pointer to the base class. And within that base class, now see what is happening. Within that pointer p, we have first kept the address of object of base class. Now what does it mean? Here we have pointer to the base class as well as the object which is being stored here is also of base class, and this is achieved with the help of the statement p is equals to %b. That means within that pointer we are actually storing the address of the object which is of the base class, which is named as b. Now using that pointer p, we are calling this vfunc by using arrow operators. So we have written p, arrow operator and vfunc. Please recall that whenever we are using pointers to the classes, in order to call the members, we are using the arrow operator, and if it is about your normal objects, you can use dot. If we want to call this vfunc using the base object or object of the base class, we can simply write b dot vfunc. But if we are talking about pointer, that means an arrow operator has to be there. So p, arrow operator and vfunc. So this is going to access the base version of the virtual function vfunc. Then with the same pointer or in the same pointer, we have stored the address of your first object or object of the derived one class, which is p is equals to ampersand d1. Now this is perfectly, we can say, valid and legal, that within the pointer of the base class you can store the address of the object of the derived class. That is perfectly possible. So we are here we are doing p is equals to ampersand d1, and after that p is equals to ampersand d1. With the help of p we are calling vfunc. Now this pointer p is basically pointing towards the object of the derived class. So here the version of vfunc which will be accessed will be from derived 1. So now please try to understand what is determining, or which function or which version of vfunc will be called is actually we can say determined by the object which is stored inside the pointer, not by the pointer itself. Let us consider a similar situation, that now that the pointer is having address of the object of the class derived 2. So that is p is equals to ampersand d2, and now with this p which is containing the address of the object of the class derived 2, we are calling, or we are trying to access derived 2's version of vfunc by using the statement p arrow operator vfunc. Now if we can see this main function, what in a comprehensive and collective manner, that what has happened actually. So we have one base pointer and 3 objects of the base class and derived class 1, derived class 2. Now initially we have taken the pointer to the base and we have stored the address of the base object there and accessed the function which is vfunc. Next we have stored the address of object of derived 1 inside the pointer p, and then tried to access vfunc. Similar exercise is being repeated for your address of the object of derived 2, which is p is equals to ampersand d2, and then we have accessed vfunc one more time. So initially when we have started with p is equals to ampersand b and we have tried to access the virtual function, that virtual function that time will be accessed from the base class, or the base class virtual function is accessed. Then whenever we have stored the address of derived 1's object, the version of vfunc which is available in derived 1 will be accessed. On the similar lines, when we are storing the object of derived object, the address of the object of derived 2 inside the pointer p and trying to access vfunc, that means the derived 2's version of vfunc will be accessed. So now what is happening here? In this situation we have created one function vfunc inside the base, named it as virtual function, and derived 1 and derived 2 classes which are inheriting this base class are actually we can say redefining this vfunc with the same prototype. I am again repeating, with the same prototype, and then with the pointer to the base class having different addresses of the different objects of derived 1, derived 2 and base, we have tried to access this vfunc. And what kind of output we are expecting, or what kind of output it should be? This should be whenever we have tried or whenever we have stored ampersand b, that time this will give us, this is base vfunc, that means version of vfunc is being called from the base class. Then when we have stored the address of the derived ones object, after that on accessing vfunc, this will say this is derived ones vfunc, that means derived one's version of vfunc has been called, and then derived 2's version of vfunc has been called when your pointer p is having address of the object of derived 2. So that means what we have achieved till this point. Virtual function is declared inside the base by the virtual keyword, and redefinition is given by derived 1 and derived 2 without the keyword virtual. Then base class is inherited by derived 1 and derived 2, and inside each class definition of vfunc is given again. And 4 variables we have declared inside the main: base class pointer, object of base, object of derived 1 and object of derived 2. And then next here p is assigned the address of b and vfunc is called via p. Since p is pointing initially to an object of type base, the version of vfunc is executed. Next, p is set to have address of d1, vfunc is called by using p1. This time p points to an object of type derived 1, and this causes derived 1's version of vfunc to be executed, and the similar thing will happen with d2. Now what is the key point? The key point is the kind of object to which p points determines which version of vfunc is to be executed. I am repeating, the kind of object to which p points determines which version of vfunc is to be executed, and this determination is done at the runtime, and this process forms the basis for runtime polymorphism. So in this lecture what we have studied, we have studied about the virtual functions, their kind of, we can say, what kind of mechanism, why they are used as the basis for runtime polymorphism, and how we can use this virtual function in order to implement one interface multiple methods, and this we have seen with the help of a program, and there we have used one pointer there, and here is a list of references which is being used for the preparation of lecture. Hope you had a fruitful learning. Thank you.